Hello, I'm Markus Hebach from Solace, and my topic today is authentication and authorization strategies or technologies for event meshes. So let me dive directly in, and this is my agenda. So first I want to quickly show the aim of the session. What do I think I can achieve? Then I have some sections like definitions, general thoughts, the categories, the different categories of authentication, authorization in event meshes, also from the perspective of an event broker, just showing the difference. The different types of connections in terms of admin connections, client connections, which protocols can you use with which technology, authentication and message flow from a mesh perspective, what happens in the mesh. And I have a little example from the connected car use case. So how to set up an IoT example and authentication, authorization in there. And if time permits, I can also show code examples for authentication in Java and probably how to create a certificate. But it is more like a technical topic, which is, we also can connect afterwards and deep dive into that, which typically makes more sense. But let me start and see how far we get. So first, the aim of the session, because it is a very complex topic, I really can scratch the surface and I do it mainly from a Solace perspective. So because the topic event mesh is something which is coined by Solace, and it's really the only real event mesh. So it makes sense to look at it from this perspective. I want to show the most relevant strategies and technologies in this area. I want to involve more people into the topic. So everyone, not just cybersecurity teams, should be involved in already thinking while developing what, say, outside things beyond your business logic is important. And authentication, authorization is one of them. And it kind of shapes also your application. And of course, I want to stimulate the discussion and create follow-up activities, maybe workshops, hackathons, or things like that. Depending on your interest, we and I can achieve that. So let's go for the, say, general definitions. So obviously, some you might know it already, but to get sure. So authentication is basically proof who you are, where you are, or who you are, that you are who you claim to be, right? So that's kind of the connecting and say, this is Markus, and I want to access a certain queue, and I want to publish messages. So that would be a typical authentication is I am Markus, and somebody needs to check if I'm really what I am saying. Yeah. So, and that involves typically like systems outside of the event mesh. If you have identity providers like Azure, Active Directory, Okta, Ping, and so on, they could be involved, and you can delegate part of this authentication. So, but I talk a little bit more about the flow of authentication. And authorization is basically, now that we know who you are, let's see what you're allowed to do. So we look on a list. Markus can publish to a queue or subscribe to a topic. So that is basically happening after authentication, and the system finds that out in several different technical ways. So, and this happens basically here in my presentation. It's kind of the idea what happens inside the event mesh from a broker perspective. So let's go to the next, right, to the categories. And in the categories, I wanted to show what type of connections exist when you look at the mesh, and you can see from, say, the outposts of a mesh. Yeah. So an event mesh is obviously a network of event brokers which are connected to each other. And from the outside, you basically always have the one event broker as the outpost, basically, to connect to. And then the broker will receive messages and then will distribute the messages through the inter-broker connectivity. So that is important. And you have different type of applications or technologies which are connecting to the event mesh via the event broker then. Yeah, so it's kind of admin connections via the UI. So you have an admin UI where you can set certain kind of values for queues and stuff like that, or you have APIs to automate things like that. So they have different ways of connecting and authenticating and authorizing, right? So you also have typical client connections, but the client connections are not all the same. They also differentiate in kind of via which protocol or which API do they connect, and each protocol or API might have different capabilities in order to connect to the event mesh via the, say, the edge broker, let's call it like that. Then you also have frameworks or application types like Node-RED or Mendix. There's a low-code application. What can they achieve by using a certain protocol? Yeah. And that is not always, they cannot always use the full capabilities of the protocols. That's just kind of what I wanted to mention, and I can get back to that later as well. And we also have iPass connectors or other connectors which act as a kind of client in terms as a publisher or subscriber. Yeah. So, and all these different kind of connections have specialties within how do they authenticate, how can they authenticate, but it's more or less very similar for the authorization part. Yeah. And how that works, I want to show now. So at a glance, so authentication can be done by enforcing your ID in the broker or LDAP radius systems, yeah, like Active Directory. That is kind of the simple way. You can use Kerberos tickets or TLS certificates, which are two technologies. Say Kerberos used in the Unix system, TLS certificates is widely used in different systems and mainly also or very often in IoT scenarios. And then the other one is OAuth 2. So you can use JSON Web Tokens and OpenID Connect tokens in order to authenticate against the broker. So and this alone is just covering, I think, say 95% of the modern technologies available today. Yeah. So the authorization is always done kind of by so entitlement of the policies based on the identity retrieved from the authentication. Yeah. So you could also use LDAP, IP address, topic wildcards, or things to kind of find the rights or the authorization for that specific entity which is connecting. I say entity because it could be a user, it could be a machine, yeah, it could be something. So I would not always say that it is a user or something. Of course, you can also use off-broker subscription management. This is some enhanced functionality, and I will also show that. Yeah. But let me first go through the kind of overview again, just to get sure that we have it in one go, right? So we have authentication with all the options. We have client authorization. So based on different values, we can authorize it, or we can use authorization groups. Yeah, so it kind of maps a combination of capabilities the entity is allowed to do. So I will also show a little bit more on that. And we have this real-time policing. Yeah, so if you do a connection to a broker, so you also say what you want to do in this connection. That is a typical flow, what is called a flow. When you connect, you get authorized, And in your connection, you say, I want to subscribe to the topic orders Germany new or something. Yeah? And the broker automatically checks, are you entitled to that in his ACL list? So it's automatically when you connect, when you authenticate it, this is happening directly. And if you cannot do it, you get an exception in your corresponding application, in your programming language, or in your protocol, which is calling that functionality. Yeah, so it's kind of really, you cannot do anything which is not allowed. Yeah, that is important. And one other important element is that it is distributed, but that's also an important element which I show. Yeah. Just quickly from the view of admin connections, which is important, that admin connections are separated in terms of they are not usable for messaging, for sending and receiving messages or events. Yeah? So admin connections are always kind of isolated from this part. You can create users which can receive and send messages from an admin perspective, but the admin cannot itself do that. That is an important security isolation principle. Yeah? And of course, in admin connections, to automate things, say you want to deploy a broker in a certain cloud, and then you want to create ACLs, and then you want to create, say, users and stuff. So that can be done automatically via the API, SAMP called, where you have basic authentication and OAuth. But you can also do it in the UI of the broker. Then you have the typical user-specific types of connecting, of authenticating, right? So single sign-on solutions are typical, like Azure AD, Ping, Okta, and so on, what I mentioned, to do that. And also, there's an option to use API connections to the Solace Cloud API, which is kind of also an automation mechanism to deploy and configure event brokers and services, and do that via JWT token, Java Web Tokens. Yeah, so that's kind of another way of automating and optimizing the flow. So for the client connections, if we look at it, you have always certain capabilities which make sense in the context of this specific programming language. Yeah, so from a Solace perspective on the Solace API, just that basic username password is always working. And for the Solace specific API, which is available in this shown programming languages or technologies, you have different options beside basic username password and of course certificate-based connectivity or authentication. Yeah. So, and the good thing is OAuth 2.0 is supported in every language. I think that's important, even if the language itself has to achieve the goal to retrieve the OAuth token from an IDP or from any source. But that is not the problem of the broker. That is kind of the delegation idea. Yeah? There's also a way of an OAuth token refresh. That means for authentication, you can say that the token has just a certain validity for a certain time. That is another security measurement. And when you have, say, a token which is valid for 1 hour, you can also kind of automate the token refresh where you ask the IDP again, give me a new token. Yeah. And that minimizes the, say, the time an unauthorized unauthorized entity has access to the system. Yeah? So, like automatically, if it kind of is say needs to be refreshed and it doesn't get the refreshed token, then it will automatically disconnect it. And Kerberos is still also supported in the typical areas where you have a kind of real real programming language. That's saying JavaScript is a real programming language. It's kind of not a server-based, even though JS is server-based, but still it is kind of not in this area to have Kerberos. And I think Kerberos is also not too famous in the meantime. Yeah. So also some client connection information. So if you look at different protocols, so then you have client certificate is basically for all enterprise messaging as an SMF and so on, and JMS also counts as an enterprise messaging API. It's also available for OpenMama API, for REST, AMQP, or MQTT. So certificates is really almost everywhere. Yeah. Kerberos is only available for the JMS and SMF APIs and OpenMama. OAuth works through the board for every protocol. Yeah, so protocols like MQTT, AMQP, JMS, and I have also code examples how to show, which show how to connect via different protocols in Java to the broker. Yeah. But here's the note: not all client connectors which using a supported protocol like MQTT are capable of doing that. So I think that's an important element that, for example, the implementation of the specific connector within a framework or in an application, space, or kind of Mendix is a low-code platform. Yeah, so but the implementation of the MQTT connector is kind of limited because there's a kind of logic implied, same as Node-RED, which is used very often in IoT scenarios, that you can only connect to the broker via a secured connection with certificates. Even if Solace or the broker itself does support TLS with username, password, and things like that, or OAuth, these platforms cannot do it, right? So this is always a consideration you need to keep in mind when connecting to the event mesh from different technologies. So when we look at authorization, we have two elements in the broker, and that is applied after the authentication. So it's basically always the same. So that means we have a client profile, which are associated with the client username, account, or any kind of token value inside your authentication token, which gives you, say, rights like how many messages can you send per time, things like that, more technical values which are allowed for this entity. And the ACL profile is more oriented in terms of which topics or queues can you subscribe or publish to. Yeah? So this is more like a logical access control list for specifying a wildcard for a topic address where you allowed to subscribe or publish to. Yeah? So this is the combination of both elements are used for complete authorization then. Yeah? So that is an important part. If it gets really complex, we have even an additional way of finding out what rights does a client have. So for example, you create your own app which contains the logic to figure out what clients are allowed to access. So that means you just connect your on behalf of application and your logic. Yeah, this is something you have to write. So then you connect to the broker and you subscribe to a certain topic. And then if a client app logs in with a certain username, for example, and it publishes a subscription request to subscribe username, that will be sent to this application. The application can then figure out what subscriptions are possible for this username. And it gives back basically this logic. It can be databases, it can be a data store, it can be a serverless function or something complex. It can also have a logic like, if it's Wednesday afternoon after 4 and the username is XYZ, then it can subscribe to a certain topic. Yeah, so it's more like a really complex scenario possible here with using on behalf subscriptions. And when we look at it from a event mesh perspective, there are certain things happening after you authenticate, right? So if we look at the flow, we say, okay, a client authenticate on broker 1. Then the broker checks the local authorization. What can it do? And then the clients publish messages according to his authorization. Yeah. So when then another client connects on broker 2, and the brokers are interconnected, so the interconnectivity is called what we call whether broker bridges or dynamic message routing, where you can establish broker-to-broker connections with certificates or basic authentication. That's a very safe way of connecting them. But they then enforce or kind of check the local authorization to its own rules. Yeah, so that means a client connects, it authenticates, it will be authorized to a certain topic address. And now, if it subscribes to this topic address, which this other client is kind of publishing to, the brokers exchange subscription information and see if they have a client which is interested in the other part. Yeah. So, and if they have the rights, the clients, then the message will be transported to the client which is interested in that subscription from a different broker. Yeah. That means you actually decouple that, and each broker can use the best method for authentication based on the use cases. IoT is a different business logic application. On the protocol, what protocol capabilities do you have? What platform capabilities have? What systems do you have? Do you have an AD, an IDP or not? So this is, it is kind of on a broker per broker decision, but you still have the global capability to configure and control it from a central perspective, from your cloud console. Yeah? So this is a very flexible way and a very secure way to do authentication and authorization in a distributed way. It's basically a self-learning, decoupled way of dealing with that scenario. So just the important points so far. In an event mesh, yeah, so it allows you basically to decouple clients from authentication methods. So if you have an IoT scenario, you can use MQTT with certificate-based authentication for sensor data for publishing. And for the same event stream of the sensor data, business apps can connect via different protocols and different security measurements. Yeah? So OAuth is one of the best methods, in my opinion, to delegate identity handling. So because in OAuth 2, you can specify, I only want, as a kind of the broker authentication, I want to have a token and a value which kind of allows me to see what this entity is entitled to. And that can be mapped, but it delegates the kind of say complex task of, for example, using multi-factor authentication and other security measurements. Multi-factor is more than two-way, it could be three-way multi-factor. It could use other technologies which are coming up in the future, but since it is kind of isolated or kind of abstracted from the actual authorization, so it kind of, the IDP does all this stuff, and of course the client code also need to do all this stuff, so that's kind of the only trade-off, because then you have more complex client code, but from a broker perspective, it's the most clean, or it's the cleanest way of doing that. So each broker can decide what to use on kind of best fit, based on the best fit for the purpose, and can be still centrally managed, as I mentioned, automated to the cloud console and APIs. And just having this different various options for authentication provide the best security, because you don't have to squeeze in your application or your implementation into a certain limited kind of authentication option. You can use the best one, and then also you can increase adoption within your developer community. So it's kind of a lot of points which are kind of, between the lines or behind the scenes, actually, which makes sense in this case. So just one additional part is an example for IoT, where kind of just one key element is important. I want to show that still the complete as a use case, and you can imagine, because everybody more or less understands what a connected car does. It's kind of cars do send sensor data to a backend, and enterprise applications kind of process it and then send it back, or kind of route it basically to an application, an app, an iPhone app, or something like that, or just process the data in terms of analytics or things like that. So, and I think the most important steps is, of course, if you do it, maintain yourself, you just use all these measurements like hardened OSs and so on, or you use Solace Cloud, where this is done for you. Then you create the container, which means you create the broker services. So you can do that yourself, or it can be done by the Solace team in the cloud already. And then you configure the external firewall in terms of let traffic in to the DMZ, and from DMZ you kind of set up the traffic into the main broker. So also an idea behind that is that you have different brokers here. It's not just one, because the connection handling is one thing which kind of puts the most load on a typical broker. So, and then you can say edge brokers handle 100,000 millions of connections. And then the internal route here, it's also an event mesh, right? It's at least here we have a couple of brokers. Here we have one internal, or a couple of internal brokers, which are bigger, others are smaller, or are the other way around. And that can handle the traffic. So you would kind of connect the internal firewalls, as mentioned. You create the ACLs, and you create topic ACLs for the multitude of devices. So imagine you have kind of a couple of million cars connected. Then you need to do something clever, because it is difficult to create ACLs for each car. So even if each car typically has kind of a certificate, and this certificate contains something like the ID, the vehicle ID, or something like that, still you would have 20 million to 2 million ACLs, which is too complicated. And that's it, why we have a special feature for that. So we can use substitution variables and topic ACLs in order to simplify that all. So you can use support variables within the ACL. Yeah, so if a car publishes to from car and vehicle ID or username, yeah, and subscribes to that, it will actually look like this. So you disallow everything and you allow only from car, and you have the substitution variable of the client username, which is contained in the certificate, right? And also on the other way around, also when you kind of subscribe, you have the same. So this keeps cars from publishing on behalf of other cars. Yeah, so that's not possible. And also that other cars, or that cars do not get messages which are meant for other cars. It would be really awkward if you press lock doors or unlock doors in your app and another car opens. Yeah, so this is a simple way of a very complex, say, scenario to achieve that by using substitution variable on topic ACLs, which is an authorization, part of the authorization for distributed systems and event meshes, right? So as we are out of time, I would like to show you examples in code, but please connect with me directly, and then we can go through how to create a certificate and how to upload it to the broker. I will also be able to give you OAuth 2 code in Java for all the different protocols, for SMF, AMQP, JMS, for all the different systems. And yeah, then I can only say, please contact me on this address, and thank you for your time. And I hope we have a vivid discussion on the topic, because it's a very interesting technical and security oriented topic. Thanks a lot.